does trigonometry actually mean? In Greek, this red part means triangle and the blue part means measure. Trigonometry is one of the most feared topics in mathematics, but in reality, it is extremely simple. The meaning itself is so simple. It's just the measure of all the things possible in a triangle. That's all. Let's consider a triangle ABC. Let A be the length of the side opposite angle A, and similarly, let B and C be the lengths of the sides opposite angles B and C respectively. Take a close look at the triangle. What all can we measure in this triangle? We can measure the angles, angle A, angle B and angle C, or find the lengths of the sides, which in this case are A, B and C. These are the only 6 things we deal with in trigonometry. 3 sides and 3 angles. Out of these 6, we are given a few, and using trigonometry, we need to find the rest. It cannot be difficult. Actually, it gets a bit simpler as trigonometry generally deals with only one kind of triangle. A right-angled triangle, which is also referred to as a right triangle. This right triangle is right-angled at this vertex. The good news is that one angle is known and only 2 remain. This one and this one. Let this angle be theta. This is the triangle we will be dealing with to cover most of our trigonometry. A triangle with an angle theta and a right angle. It doesn't have to be called theta, but that's what it is generally referred to as. But how do these kind of triangles help us in real life? How does trigonometry help us in real life? Let's say Zen wants to find the height of this tree. He has to measure this length, which is the height. One way is to make an approximate guess, but a better way to find the height is by using trigonometry. Let's assume this distance is known to us. Remember, it's always easier to find the distance or the length on the ground than finding the distance vertically. And we can find the approximate measure of this angle, which is theta. With just these 2 pieces of information, Zen can find the height of this tree. Finding the height of a tree may not sound appealing to you, but the next example surely will. This time, Zen wants to find the height of a mountain. If this distance is known and this angle is known, then the height can easily be found out. But how? That's precisely what we will try to understand in trigonometry.
So before we start doing trigonometry with the angles and side lengths in right triangles, we need to start by getting a little vocabulary together to talk about angles and sides and how they're related. So depending on which non-90 degree angle we're looking at in the triangle, we're going to name the sides of the triangle. So I'll show you what I mean here. Let's work with the angle in the lower left-hand side of the triangle, the non-90 degree angle, and I'm going to go through the names for the 3 sides based on that angle. Well, we can start with the hypotenuse. The hypotenuse never changes. It's always the longest side. But now the 2 other sides are going to be based on the angle. So the one directly across or opposite from the angle is the opposite side of the triangle. And then the one right beside the angle, the side that's right beside the angle but is not the hypotenuse, is called the adjacent side. So this is the same triangle as before, but let's see how it changes when we use the other non-90 degree angle. So now we'll use the angle at the top of the triangle. Well, the hypotenuse is still the hypotenuse. because it's still the longest side. That hasn't changed. But now, the side that's directly across from the angle is going to be the opposite side. And the side that's right beside the non-90 degree angle that we're using is called the adjacent side. And again, it's the side beside the angle that is not the hypotenuse.
A simple way to memorize trigonometric ratios. For any acute angle of a right-angled triangle, there are 6 trigonometric ratios: sine in short sine, cosine in short cos, tangent in short tan, cosecant in short cosec, secant in short secant, and cotangent in short cot. These ratios gives the relationship between the angle and the sides of the triangle. For angle A, opposite side is side BC and adjacent side is side AB. For angle C, opposite side is side AB and adjacent side is side BC. The sine of an acute angle is defined as the ratio of the length of the side that is opposite that angle to the length of the longest side, that is the hypotenuse, of the triangle. The cos of an acute angle is defined as the ratio of the length of the side that is adjacent that angle to the length of the hypotenuse of the triangle. The tan of an acute angle is defined as the ratio of the length of the side that is opposite that angle to the length of the side that is adjacent that angle of the triangle. The cosec of an acute angle is defined as the ratio of the hypotenuse to the length of the side that is opposite that angle of the triangle. The sec of an acute angle is defined as the ratio of the hypotenuse to the length of the side that is adjacent that angle of the triangle. The cot of an acute angle is defined as the ratio of the length of the side that is adjacent that angle to the length of the side that is opposite that angle of the triangle. Let us try to remember the first 3 trigonometric ratios. Memorizing this mnemonic will help us to remember the trigonometric ratios in correct order. The mnemonic is as follows. Students of Heston College always have trouble over accommodation. Sine theta is equal to opposite side of angle theta divided by hypotenuse. Cos theta is equal to adjacent side of angle theta divided by hypotenuse. Tan theta is equal to opposite side of angle theta divided by adjacent side of angle theta. Now, we can memorize the next 3 trigonometric ratios, that is cosec, secant and cot ratio. Cosec and sine ratio are reciprocal, that is multiplicative inverse, of each other. Secant cos ratio are reciprocal of each other. Cot and tan ratio are reciprocal of each other. We know sine ratio. Sine theta is equal to opposite side divided by hypotenuse. Also, cosec and sine ratio are multiplicative inverse of each other. Hence, we can easily write cosec ratio. Cosec theta is equal to hypotenuse divided by opposite side. Now the next, that is sec ratio. We know cos ratio. Cos theta is equal to adjacent side divided by hypotenuse. Also, sec and cos ratio are multiplicative inverse of each other. Hence, we can easily write sec ratio. Sec theta is equal to hypotenuse divided by adjacent side. Now the next, that is cot ratio. We know tan ratio. Tan theta is equal to opposite side divided by adjacent side. Also, cot and tan ratio are multiplicative inverse of each other. Hence, we can easily write cot ratio. cot theta is equal to adjacent side divided by opposite side. Once again we can repeat the trigonometric ratios. Sin theta is equal to opposite side divided by hypotenuse. Cos theta is equal to adjacent side divided by hypotenuse. Tan theta is equal to opposite side divided by adjacent side. Cosec theta is equal to hypotenuse divided by opposite side. Sec theta is equal to hypotenuse divided by adjacent side. Cot theta is equal to adjacent side divided by opposite side. Interrelation between trigonometric ratios. Sin theta is equal to 1 divided by cosec theta. Cosec theta is equal to 1 divided by sin theta. Cos theta is equal to 1 divided by sec theta. Sec theta is equal to 1 divided by cos theta. Tan theta is equal to 1 divided by cot theta. Cot theta is equal to 1 divided by tan theta. Tan theta is equal to sin theta divided by cos theta. Cot theta is equal to cos theta divided by sin theta.